To maintain the necessary separation between the conductor and the shields, a portion of both shields is cut back from the end of the cable and removed. As shown in this side view, the insulation shield, the metallic shield tape, and the concentric wires have been layered back from the insulation to separate them from the conductor. When this is done, however, there is no voltage stress control beyond the shields. Where the shields are intact, the voltage stress is evenly distributed through the insulation so that it's not concentrated in any one area. However, where the shields have been removed, the lines of voltage stress curve back and concentrate at the points where the shields end. Without some means to control this stress, the insulation could break down, resulting in a cable failure. There are two basic ways to control voltage stress. One way is by increasing the thickness of the cable insulation at the point where the insulation shield terminates. Insulation is added from the end of the insulation shield to a specified distance along the exposed factory-installed insulation. Layers are added so that the insulation forms a cone with a thickness specified by the termination instructions. A variety of insulation materials can be used to build the stress cone, including non-conductive rubber tape, varnished Dacron glass cloth, or other approved insulating material. After the insulating material is added to increase the thickness of the cable insulation, the insulation shield is extended up the stress relief cone to just before the high point of the cone. The material used to extend the insulation shield is usually a semiconductive tape or a metallic braid, as shown here, or both. Increasing the insulation and extending the insulation shield spreads out the voltage stress over a larger area so that it's not concentrated at any given point. Another way to control voltage stress at a termination is by applying a capacitive material over the termination area. This capacitive material has a much greater ability to store a charge than most common cable insulations. The measure of a material's ability to store a charge is called its dielectric constant and is sometimes referred to as its K factor. The higher the K factor, the greater the material's ability to store a charge. As shown in this chart, most common cable insulations have a K factor in the range of 3 to 6. The capacitive material, however, has a K factor of 30. At the termination, this higher K factor enables the capacitive material to concentrate the voltage stress in itself so that it doesn't concentrate at any given point in the insulation. So, voltage stress may be controlled at a termination by building a stress cone or by applying a highly capacitive material. Now, besides controlling voltage stress, a termination may also need tracking protection so that current doesn't track from the conductor terminal to the grounded insulation shield. Tracking is discharges of current across the surface of an insulated terminal. Tracking can result when three conditions are present. These are voltage on the conductor, contamination on the termination, such as dust, chemicals, or salt, and moisture on the termination, such as moisture from humidity, fog, condensation, and rain. Tracking is reduced or eliminated on high voltage terminations by using skirted tracking-resistant materials to cover the termination. Two common tracking-resistant materials used for high voltage terminations are porcelain and silicone rubber. The skirts increase the creepage distance between the energized conductor and the grounded insulation shield. The higher the voltage, the greater the size and number of skirts needed to prevent tracking. In addition to controlling voltage stress and preventing tracking, a high voltage termination may also need to seal the cable from the environment, and if the cable is pressurized, to seal the pressure within the cable system. A termination is sealed by applying a sealing material both at the top and the bottom of the termination. Common materials used for sealing a termination include rubber tapes, solder, and for some applications, gaskets. Finally, a high voltage termination may need to reduce the voltage stress that can result in corona discharges around the outer surface of the cable. This is done by connecting the metallic cable shielding to ground. This allows any voltage on the insulation shield to drain to ground and keep the outer surface of the cable at or near ground potential.